avoiding pepper. It's a really simple experiment and you only need a couple of things to do it. For this experiment you need a bowl, some water, washing up liquid and pepper. Very simply, pour your water into a bowl, preferably something that's quite wide. Then sprinkle a lot of pepper onto the surface of the water. You need to make sure it's fairly well covered. Once you've done that, get your washing up liquid and place a very small amount onto the tip of one of your fingers. Then place your finger into the middle of the bowl. You'll see that the pepper seems to run away from your finger. Well, it's not the pepper that's running away, but in fact it's the water underneath the pepper. The washing up liquid on the tip of your finger reduces the surface tension of the water underneath it. This means that the pepper has to stay on top of the water with a higher surface tension, and so gets as much distance between it and the finger as it can. It's almost like magic, but it's science really. And that's how you demonstrate avoiding pepper. Dancing raisins. Now this is a really easy experiment. All you're going to need is a bowl of raisins, a bottle of soda water and a glass. Very simply, pour some soda water into the glass, make sure that it's nice and full. You'll see that loads of bubbles are floating to the surface. The next step is to drop some of the raisins into the soda water, and instantly you'll see that they seem to be dancing. This is because the tiny bubbles of carbon dioxide inside the soda water are latching onto the tiny wrinkles on the raisins. The more bubbles that latch on, the more gas there is stuck to the raisins, and the more gas there is, the lighter they get, and so they start to float to the surface. When they hit the surface, some of the bubbles pop, which makes the raisins heavier again, and they sink to the bottom. This process then continues to repeat. And there you have it. That's how you really easily make your own dancing raisins. Diving ketchup experiment. For this you're going to need a bottle of water, a sachet of sauce, preferably ketchup. The first step is to take your bottle of water and your ketchup. Then unscrew the lid. Make sure that the bottle is completely full of water. And then very carefully insert the sachet of sauce into the bottle. You'll find that water spills out of the bottle when you do this, but that's fine. Once that's done, very carefully and tightly seal the bottle. You'll see that the ketchup packet floats inside the water. But if you squeeze the bottle, it sinks. Let go and you'll see that it rises to the top again. Why is this? Well, it's because inside the ketchup packet there is also a very small bubble of air. When you squeeze the bottle, you compress the air inside the packet, which makes it denser, and therefore it sinks to the bottom. When you let go of the water, you release the pressure, and it means that the air inside the packet becomes less dense, and so rises back to the top of the bottle. You can play around with this for a while and see how quickly you can make the packet sink and how quickly you can make it rise. If you get the pressure just right, you can make it float directly in the centre of the bottle. Why don't you challenge your friends at this and see who's best? You could even have a race to see who's fastest. And there we have it. That is the amazing diving ketchup experiment. Duck call at home. Now this is one of the easiest experiments we've ever shown you. All you need is a pair of scissors and a straw. First of all, start to flatten out your straw. This will become very important later on if you want to make a good duck call. If your straw has a bent side, make sure you cut it off. Then, very carefully, cut one end of the straw into a point. You'll see that the end has two pointed triangles, much like a duck's beak. All you need to do now is put the flat end of the straw into your mouth and breathe in sharply. The sound that you're hearing is caused by the pointed ends of the straws vibrating very fast together, creating a duck call. And there you have it. That's how you make your very own duck call at home. Motion on the ocean. For this experiment, you're going to need some baby oil, a funnel, some blue food dye, a bottle, and a jug of water. First of all, add some blue food dye to the water. Give the jug a bit of a stir, and then use the funnel to half fill the bottle with your blue water. You might find that doing this causes some bubbles to form on the surface of the water. If that happens, just leave it aside for a few minutes and they should go away. Then take your bottle of baby oil and very carefully fill the bottle the rest of the way with oil. Try to make sure there's as little air left in the bottle as possible. Once that's done, take the lid and fix the bottle securely. You need to make sure that none of the oil or water pours out. Then, very simply, take the bottle and turn it on its side. You'll see that inside the bottle you seem to have an ocean where the waves are churning and turning. This is because the oil and the water have different densities. They never mix together properly and so stay separate, with the oil floating on top of the water. Now this is a really cool experiment which demonstrates the difference between different densities of liquids. You can play with the bottle, turn it end to end or side to side, and see the way the waves take shape. And there you have it. That's how you make your very own motion on the ocean at home. Put out a candle without blowing it. Now this is a really fun experiment, and what you're going to need to do it is 1 candle, 1 tablespoon of baking soda, 1/4 cup of vinegar, a sheet of paper, a plastic bottle and some matches. What you need to do first of all is roll your paper up into a cone shape. Then place your cone into the top of your plastic bottle and pour in the baking soda. Be careful not to spill any. Brilliant. Once you've done that and you're sure all the baking soda is inside the bottle, take the cone out and pour in your vinegar. You'll see bubbles start to form inside the bottle. Then take your candle and light it. Tilt it towards the candle. Get ready kids, because this is amazing. You'll see the flame goes out all by itself. Wow, isn't that cool? It's just like magic. This happens because the carbon dioxide is heavier than the rest of the air inside the bottle, so that when you tilt it, the carbon dioxide comes out first and puts out the flame. This is because flames need oxygen to burn. And there you have it. That's how you can put out a candle without actually blowing it. Snake bubbles. All you're going to need is some rubber bands, a big plastic bottle, a pair of scissors, some white socks, a small plastic bottle, some food colouring, bubble mixture, and a glass. Firstly, carefully use your scissors to cut off the bottom of your large plastic bottle. It's best to ask a parent to help you with this, as the scissors may be sharp. Smooth off the edge of the bottle so there are no sharp pieces. Then take your sock and again use the scissors to cut along the end of the elastic part of the sock. Then carefully stretch the fabric of the sock around the bottom of the bottle. Pull it tightly so you create a sort of drum made out of material. Make this surface as tight as you can. Once that's done, use a rubber band to hold the sock in place. Next, pour your bubble mixture into a container. Make sure that the container is wide enough for you to dip the bottle inside. Take the bottle and dip the sock end into your bubble mixture. Make sure there's plenty of mixture on it. If you blow into the neck end of the bottle, you'll see that you create thousands of tiny bubbles. This is because the fabric of the sock has tiny holes inside, creating lots of little bubble blowers for you. Now, how can we make this more interesting? I've got an idea. What you need to do is take your food dye and pour some over the end of your bottle. You can do this in spots, in stripes, or you could just completely soak the end of your sock in food dye. I'm going to start with a little red and blue, just to see what happens. Let's cover a good amount of the surface in food dye. Once that's done, take a deep breath and blow. You can see that as the bubbles come through the sock, they soak up some of the food dye, creating coloured bubbles. This is a really fun experiment. You can try with all sorts of different coloured food dyes. You could even try different socks to see what gives you the best bubbles. And that's how you can make your own snake bubbles. Singing glasses. This is a really cool experiment. And all you're going to need is 2 wine glasses, a cocktail stick and some water. Take your 2 glasses and put them very close together, but not quite touching. Then pour some water into one of the glasses until it's about half full. Then carefully pour water into the second glass until it matches the level of the first. If you go too far, you'll need to pour some water into the first glass so that it matches. Make sure you're completely confident that the water level is exactly the same. If you prefer, you can measure the water beforehand. Then take your cocktail stick and place it carefully on top of one of the glasses. Then wet your finger and rub it along the edge of the first glass. Can you hear the glass singing? Well, that's because that as you rub your finger along the edge of the glass, it causes vibrations, which in turn create sound. And as you can see, the vibrations seem to be working in the second glass as well, even though they're not touching. Well, this is because the water level is the same in both glasses, and so their vibrational frequency is the same. When another object picks up the same vibrations as the first, we call this a sympathetic vibration. These tiny vibrations not only create sound, but movement as well, and that's why the cocktail stick seems to move all by itself. And there we have it. That is the amazing singing glasses experiment.
Scary slime. Isn't that cool? For this experiment you're going to need 2 bowls, 1 teaspoon of borax, half a cup of PVA glue, a spoon, half a cup of water, another cup of water, green food dye and a Ziploc bag. What you need to do first is mix your teaspoon of borax with 1 cup of water. Use the spoon to stir the mixture until all of the borax is completely dissolved into the water. Keep on stirring. Then you need to get half a cup of water into your bowl. Add the green food dye. Get it right in there, enough to make it a really cool colour. And then add the PVA glue. Stir the glue into the water and the food dye mixture until it starts to swirl and you get a thick, gooey paste. You'll see that the colour is completely mixed in with all of the glue and the water. Then you take your borax mixture and mix it into the glue mixture. You'll see that it very quickly starts to thicken. Use the spoon to continue stirring the mixture until it gets thick enough to use your hands. Then use your hands to pull all the separate strands of goo out and separate it from the water using your second bowl. At this point, it should be really slimy and gooey. Disgusting! Make sure you get as much of the mixture separated from the water as possible. Did you know the PVA glue in the scary slime is called a polymer? When a polymer mixes with the sodium borate, or borax, they combine to produce one giant new molecule. This new compound is able to absorb huge amounts of water, which creates the slime. The first kind of slime was invented by accident in the year 1043 by James White, while searching for an alternative way to make rubber. Isn't that crazy? Take your Ziploc bag and very carefully pour what's left of the slime into the bag. Seal up the top of the bag. This will stop from making a mess. And then you can see your scary slime mixture.
The soda can jump. This is a really fun one. You're going to need mug number 1, mug number 2, and a soda can. You're going to need to empty the soda can. Once you've done that, place the can inside one of the cups and blow into the cup. You'll see that the can jumps out. You'll also see that this works regardless of which way round you put the can into the cup. Place the second cup close to the first and blow. Try and aim the can into the second cup. Why does this happen? Well, the can is very light. When you blow air into the space between the cup and the can, it creates an area of high pressure. This high pressured air forms underneath the can and pushes it. The air above the can is still at a low pressure, and so the can is able to move based on the air alone. Why not move the cups around and see what you can do? Challenge your friends to see who can score the most points. And there we go, that is the soda can jump.
Triangular. Got bigger. There we go. Oh, and smaller. Bigger and smaller. Lots of blood. Zoom in. That's what a microscope's supposed to do. So you can see
Nhắm tay cho tôi xem coi.
close up.
Đó.